Hi, everyone. I just wanted to walk you through a couple of more inverse examples, kind of more like what you would encounter on the AP. So just to kind of reiterate some of the notation that Mr. Miller went over in his video. So given that G is the inverse of F, and we know that F of 1 is 5, F of 3 is 7, and F of 8 is negative 10, we want to find G of 5, G of 7, and G of negative 10. So remember that the F of 1 is equal to 5, F of 3 is equal to 7, and F of 8 is equal to negative 10. Remember that these really just represent ordered pairs. So this is representing the 0.15, the 0.37, and the 0.8 negative 10. And if these two functions are inverses, or G is the inverse of F, remember that when we make tables of values for inverse functions, what we're really doing is we're really reversing the X's and the Y's. So this is really telling us that if we reverse these points would be on the graph of G, or the inverse graph. So if we know that F of 1 is equal to 5, then when we reverse those points, that would tell us that G of 5 would have to be equal to 1, because our ordered pair would get flipped around, or our X values and our Y values would switch places. Same idea with G of 7. If we know that the point F of 3 is equal to 7 is on the graph of F, then the point 7, 3 must be on the graph of G. And same with G of negative 10. If the point 8, negative 10 is on the graph of F, then the point negative 10, 8 would have to be on the graph of the inverse of F, or on the graph of G. So this is helpful information because a lot of times the question might ask you, for example, in example 4, it might give you a function and it might give you a point that it passes through on the function f. And what we want to do is we want to use this f of x, and we want to use this point to find the f inverse prime of 2. Which, remember that if we know that this is true, G is equal to the inverse of F, then what this is really asking us to find is really asking us to find G prime of 2. And using what we know that G prime of A is equal to 1 over F prime of G of A. So if we're looking for G prime of 2, what we're really looking for here is 1 over F prime of G of 2. And this G of 2 value is going to come from this point. So we know that this point 1, 2 is on the graph of F. So that must mean on the graph of G, the point 2, 1 is happening. So G of 2 would have to be equal to 1. So this is asking us to do F prime of 1. So if we're given F, then we should be able to calculate what F prime is, which would be 5x to the 4th plus 3. And if we calculate that at 1, that's going to tell us that this is going to be 5 plus 3, which is going to be 8. So that's going to tell us that the inverse of f prime at 2 is actually going to be equal to 1/8. Okay, so what if we're given tables of values? Well, the same rule still applies. If we know that G is equal to the inverse of f, which is going to tell us that G prime of A is equal to 1 over F prime of G of A, and we're looking for G prime of 3, then what the table is going to help us do is it's going to help us to fill in these values. So if we're looking for G of 3 here, well, G of 3 would be 2. So this is going to give me 1 over F prime of 2. And then I can use my table of values to find F prime of 2. So F prime of 2 would be equal to 1. So this is going to give me 1 over 1. So G prime of 3 would be equal to 1. Okay, so this is part 1. We will talk more about part 2 of inverse functions tomorrow. Let me know if you have any questions.